Welcome in dark core. Astronomers may have found evidence of a new planet hiding in our solar system, and it's not Planet 9. A recent study from Princeton University proposes the existence of Planet Y, a smaller, closer world that could be subtly bending the orbits of distant Kuiper belt objects. If proven, it would be the first new planet added to our solar system since Neptune. In this video, we'll explore what Planet Y is, why scientists think it might exist, and what comes next in the search for it. Let's get started. The discovery. The idea of hidden planets isn't new. For more than a century, astronomers have speculated that unseen worlds beyond Neptune could explain odd movements among distant bodies. Pluto's discovery in 1930 briefly satisfied that curiosity, but as observations improved, its small mass proved inadequate to explain the remaining anomalies. Now, new data suggests there could be more out there. In August 2025, Princeton astrophysicists Amir Siraj, along with Christopher Cheever and Scott Tremaine, published a peer-reviewed study in Monthly Notices of the Royal Astronomical Society proposing Planet Y, a hypothetical planet orbiting between 100 and 200 astronomical units, AU, from the Sun. The researchers analyzed the orbits of more than 150 Kuiper belt objects, KBOs. After accounting for Neptune's influence, they noticed something unusual. The orbital planes of objects between 80 and 200 astronomical units are systematically tilted. This warp is small but statistically significant, hinting at the pull of a massive unseen body. To explain it, the team modeled multiple scenarios: gravitational resonance among the KBOs, the Milky Way's tidal influence, and past stellar flybys. None could reproduce the observed pattern as effectively as a single orbiting planet. Their calculations suggest a body 25 to 450 times the mass of Pluto, roughly between Mercury and Mars in size, orbiting on a path inclined 10 to 15 degrees relative to the solar system's main plane. That makes it smaller and closer than the much-discussed Planet 9, which is predicted to be 5 to 10 Earth masses and roughly 600 astronomical units away. So far, no telescope has directly seen Planet Y. The evidence is entirely gravitational, a mathematical fingerprint written in the Kuiper belt's architecture. Yet, this pattern is precise enough that many astronomers now view the hypothesis as a credible, testable prediction rather than speculation. Scientific importance and theories. If Planet Y exists, it would challenge the assumption that our solar system's planetary family ends with Neptune. Its presence would imply that the early solar system produced more large bodies than previously thought, some of which survived on distant orbits. There are three leading formation scenarios. Native survivor, a planet formed near the giant planets and was scattered outward during the solar system's chaotic early evolution. Captured object, a wandering interstellar planet that passed close enough to the Sun to be gravitationally trapped. Complement to Planet 9, a smaller companion that, together with Planet 9, shapes the Kuiper belt structure. Each explanation would add a new layer to models of planetary formation and migration. Planet Y's predicted mass is also scientifically significant. A body with a fraction of Earth's mass at 100 to 200 astronomical units would have enough gravity to clear its orbit, the core requirement for official planet status under the International Astronomical Union's 2006 definition. At roughly 50 times Pluto's mass, it would easily qualify as a full planet, not a dwarf one. Confirming such a world would also refine our understanding of the Kuiper belt's dynamics. The belt is not uniform, its objects exhibit clustered angles and inclinations that suggest an external perturbing force. Planet Y could provide a straightforward gravitational explanation for this pattern. Not all astronomers are convinced. Some argue that the apparent warp could emerge naturally from the collective gravitational effects of many smaller objects. Others point out that small number statistics and observational bias might exaggerate the alignment. Nevertheless, the Princeton model reproduces observed data with fewer assumptions, keeping the hypothesis scientifically persuasive. If real, Planet Y would fill an important missing link, showing that planetary formation continues smoothly into the outer regions rather than stopping abruptly after Neptune. In broader terms, it would remind us that even within our own solar system, much remains undiscovered. Implications and what's next. The key test for Planet Y will come from observation. The Vera Rubin Observatory in Chile, set to begin full operations soon, is designed for this exact kind of search. Its Legacy Survey of Space and Time, LSST, will image the entire southern sky every few nights, capturing faint, slow-moving objects at the fringes of the solar system. At 100 to 200 astronomical units, PlanetY would be extremely dim, perhaps a million times fainter than what the naked eye can see, and moving only a few arcseconds per year. But LSST's repeated scans and powerful data processing algorithms could reveal its motion over months or years. If PlanetY exists, LSST might detect it directly or indirectly through improved mapping of distant KBOs whose orbits betray its gravitational tug. In either case, the data collected within the next few years should decisively confirm or reject the hypothesis. Should the planet be found, the implications are profound. It would represent the first new planet discovered in nearly 2 centuries and confirm that our solar system extends much farther and with greater complexity than previously imagined. It could explain why certain long-period comets approach the Sun from odd directions, and it would add a new data point for studying how planetary systems form and evolve elsewhere in the galaxy. The discovery would also settle an ongoing public debate about what defines a planet. Pluto was reclassified as a dwarf planet because it hadn't cleared its orbit. A Mars-mass world at 100 astronomical units would have no such problem, satisfying every criterion of planethood and restoring some symmetry to the solar system's outer architecture. If, however, the LSST finds no trace of PlanetY, the outcome remains valuable. Astronomers would re-evaluate the dynamics of the Kuiper belt, perhaps attributing its warp to distributed mass effects or past stellar encounters. The search itself will yield thousands of new minor body discoveries, refining our map of the solar system's edge. Looking ahead, PlanetY has already sparked discussions about future deep space missions. With advancements in propulsion, future probes might travel beyond Neptune to directly survey these distant realms, whether or not a hidden planet awaits there. The broader takeaway is that science progresses through investigation, not certainty. Each anomaly drives inquiry, and even a null result pushes knowledge forward. Outro. PlanetY remains unconfirmed, but the search continues. Whether it exists or not, the investigation expands our understanding of the solar system's edge. Sometimes the pursuit of discovery reveals as much as discovery itself. Thanks for watching Dark Core.